Imagine standing outside on a clear night, looking up at the sky. Billions of stars shimmering above, each a potential home to planets we can't even see. For centuries, humans have wondered, are we alone in the universe? Could there be another world out there? One just like Earth, with blue oceans, green forests, and an atmosphere rich with life? Until recently, these were just questions. But today, science is on the brink of answering them. The search for Earth 2.0, a planet that could support life as we know it, is no longer science fiction. It's an unfolding reality. And here's the exciting part. We are closer than ever to finding it. The discovery of exoplanets, planets that orbit stars beyond our solar system, has revolutionized our understanding of the cosmos. Thanks to powerful telescopes, cutting-edge space missions, and groundbreaking scientific techniques, astronomers have already identified thousands of these alien worlds. Some of them are rocky, Earth-sized, and orbit within the habitable zone of their stars, the region where liquid water could exist. But the big question remains, do any of them truly resemble Earth? What makes a planet Earth-like? To understand how close we are to finding Earth 2.0, we first need to define what that means. Scientists don't just look for any planet orbiting a distant star. They have a strict set of conditions that must be met for a planet to be considered potentially habitable. Size and composition. The planet must be rocky, like Earth, rather than a gas giant like Jupiter or Saturn. Location in the habitable zone. It must orbit its star at just the right distance, not too close, where it would be scorching hot like Venus, and not too far, where it would be frozen like Mars. Atmosphere. It should have an atmosphere capable of trapping heat and protecting the surface from harmful cosmic radiation. Liquid water. This is the key ingredient for life as we know it. The presence of liquid water significantly increases a planet's potential for hosting life. Stable star. The planet's star should be relatively stable, without frequent violent solar flares that could strip away the atmosphere or destroy any potential life. Finding a planet that checks all these boxes is extremely challenging, but not impossible. How are we finding these exoplanets? For centuries, humans could only speculate about planets beyond our solar system. But in the last few decades, we've developed incredible technology that allows us to detect and study these distant worlds. The Kepler Space Telescope, the game-changer, launched in 2009. NASA's Kepler Space Telescope was the first major breakthrough in exoplanet discovery. Using the transit method, Kepler looked for tiny dips in a star's brightness, caused by a planet passing in front of it. This method helped scientists confirm the existence of over 2,600 exoplanets. Among its biggest discoveries were Kepler 452b, often called Earth's cousin. This exoplanet is 1.6 times the size of Earth, orbits a sun-like star, and sits in the habitable zone. Kepler 22b, another Earth-like world that could potentially have oceans covering its surface. Kepler's biggest revelation? Planets are everywhere. Scientists now believe that almost every star in the Milky Way has at least one planet orbiting it, meaning there are hundreds of billions of planets in our galaxy alone. The chances of one of them being Earth 2.0? Very high, 1-2. The James Webb Space Telescope, peering into alien atmospheres. While Kepler was great at finding planets, it couldn't tell us what their atmospheres were made of. This is where the James E. Webb Space Telescope, JWST, comes in. Launched in 2021, JWST is the most powerful space telescope ever built. It can analyze the light passing through a planet's atmosphere to detect gases like oxygen and ozone, which are essential for complex life, methane and carbon dioxide, which could indicate biological or volcanic activity. Recently, JWST studied an exoplanet called K2-18b, a super-Earth located 120 light-years away. It found traces of methane and carbon dioxide, suggesting the presence of a water-rich atmosphere. Could this mean life? We don't know yet, but the discovery was groundbreaking. TESS, scanning the entire sky, the Transiting Exoplanet Survey. Satellite TESS, launched in 2018, is continuing Kepler's work but on a much larger scale. Instead of focusing on a small patch of sky, TESS is surveying the entire sky, identifying exoplanets around nearby stars, ones that we might actually be able to explore in the future. TESS has already found over 200 confirmed exoplanets and thousands of additional candidates, including TI-TOI 700d, a rocky planet in the habitable zone, just 100 light-years away. LHS 1140b, a dense rocky world that could have a thick atmosphere and liquid water. With TESS's discoveries, we now have a growing list of promising Earth-like worlds. So, have we found Earth 2.0 yet? Not yet, but we're extremely close. Right now, scientists have a short list of candidates that may have Earth-like conditions, but we still need more data. The next steps involve studying their atmospheres in greater detail using telescopes, like JWST detecting biosignatures, gases or chemical signs that indicate the presence of life, planning future missions that could send space probes, or even humans, to these distant worlds. The dream of finding another Earth is no longer just a fantasy. It's a scientific goal within our reach. The next few decades could bring discoveries that change everything we know about our place in the universe. But before we look at future space missions that might take us to these distant planets, let's explore some of the most promising exoplanets we've found so far, worlds that could one day become our second home. The most promising candidates for Earth 2.0, we've discovered thousands of exoplanets, but only a handful truly stand out as potential Earth-like worlds. These planets check most of the boxes: rocky surfaces, habitable zones, and promising atmospheres. But do they really have what it takes to be Earth 2.0? Let's explore the top candidates that scientists are keeping a close eye on. Kepler 442b, one of the best matches. Yet Kepler 442b is a super-Earth located 206 light-years away in the constellation Lyra. This planet is just about 1.34 times the size of Earth and receives about 70% of the sunlight that Earth gets from the Sun, which means it's warm enough for liquid water, but not scorching hot like Venus. What makes Kepler 442b particularly exciting is its potentially stable atmosphere. Scientists believe it has a good balance of heat and energy to support life. However, there's one major challenge: its star. Unlike our Sun, Kepler 442b orbits an orange dwarf star, which is smaller and cooler. While this isn't necessarily a deal-breaker, it means the planet would need a strong atmosphere to trap enough heat for life to thrive. Proxima Centauri b, the closest exoplanet to Earth. If there's one exoplanet that gets scientists truly excited, it's Proxima Centauri. Because it's only 4.2 light-years away. That may sound far, but in cosmic terms this is practically in our backyard. Discovered in 2016, Proxima b orbits Proxima Centauri, the closest known star to our solar system. It sits within the habitable zone, meaning liquid water could exist. On its surface, its size is also very similar to Earth's. But there's a problem. Proxima Centauri is a red dwarf, and red dwarfs tend to be violent stars. They release powerful solar flares that could strip away a planet's atmosphere, making it nearly impossible for life to survive. Still, if Proxima b has a strong magnetic field, like Earth, it could be protected from these flares. Scientists are still trying to figure out if this is the case. TRAPPIST-1 system, a gold mine of Earth-like planets. Now, what if I told you there isn't just one potential Earth 2.0, but 7? Welcome to the TRAPPIST-1 system, located 39 light-years away, in the constellation Aquarius. This system has 7 Earth-sized exoplanets, and 3 of them, TRAPPIST-1e, TRAPPIST-1f, and TRAPPIST-1g, are in the habitable zone. The reason TRAPPIST-1 is so fascinating is that it resembles a miniature version of our solar system, with rocky planets orbiting a central star. Scientists believe some of these planets might have water and even thick atmospheres that could support life. However, TRAPPIST-1's star is also a red dwarf, meaning these planets experience intense solar radiation. Scientists are currently using the James Webb Space Telescope to study their atmospheres. If they find signs of oxygen, methane, or other life-supporting gases, this system could become the top contender for Earth 2.0 LHS 1140b. A super-Earth with a thick atmosphere located 40 light-years away, LHS 1140b is a rocky super-Earth that is 1.7 times the size of our planet. It orbits a small red dwarf star, but at a safe distance, meaning it avoids the worst of the star's radiation. One of the biggest reasons scientists are excited about LHS 1140b is that it may have a thick atmosphere and even liquid water. In 2023, astronomers used the JWST telescope to analyze its atmosphere and found strong signs of water vapor. If future studies confirm that LHS 1140b has an Earth-like climate, it could become one of the most habitable exoplanets we've discovered. So far, can we ever reach these exoplanets? Now comes the biggest question. If we find Earth 2.0, can we actually travel there? Right now, even the closest exoplanet, Proxima Centauri b, is 4.2 light-years away. That may not sound like much, but with current rocket technology, it would take over 6,000 years to get there. So, unless we make a major breakthrough in space travel, visiting these planets seems impossible. But don't lose hope. Scientists are already working on next-generation space travel that could drastically cut travel time. Some of the most promising ideas include Breakthrough Starshot, a project that aims to send tiny, lightweight spacecrafts to Proxima Centauri b using laser-powered sails. These could reach 20% of the speed of light, getting there in just 20 years. Nuclear fusion rockets. NASA is researching rockets that could travel at 10% of the speed of light, making interstellar travel much faster. Wormholes and warp drives. While still theoretical, some physicists believe that space-time itself could be manipulated to allow faster-than-light travel. Are we alone in the universe? The search for Earth 2.0 isn't just about finding a second home. It's about answering one of the biggest questions in human history. Are we alone? If we find an exoplanet with a breathable atmosphere, liquid water, and signs of life, it would mean that life is not unique to Earth. We might not find definitive proof tomorrow or even in the next decade, but with the pace of scientific progress, the answer could come within our lifetime. And here's something to think about. What if intelligent life already exists on one of these distant worlds? What if they're searching for us too? Before we explore the future of space colonization and the challenges of living on an exoplanet, let's take a deeper look at how we might one day leave Earth behind and start life on a new world. Colonizing Earth 2.0. Can we really live there? Finding a second Earth is one thing, but colonizing it, that's a whole different challenge. Even if we confirm an exoplanet is habitable, how would we get there, survive, and build a new civilization? Let's break it down. The journey to a new world. How would we travel? Even if we found the perfect Earth-like planet tomorrow, we can't just pack our bags and move. The vast distances between us and these exoplanets make traveling there one of the biggest challenges in human history. Right now, our fastest spacecraft, Voyager 1, is traveling at 38,000 miles per hour. At that speed, reaching Proxima Centauri b, our closest exoplanet, would take over 73,000 years. Clearly, traditional rockets aren't going to cut it, but futuristic technologies could change everything. Breakthrough Starshot. Scientists are developing laser-driven spacecraft that could travel 20% the speed of light, reaching Proxima Centauri b in just 20 years. Nuclear fusion rockets. These could reach 10% of light speed, cutting travel time to just 40 years, within a single human lifetime. Warp drives and wormholes. While still theoretical, some physicists believe bending space-time could make faster-than-light travel possible. If proven, it would change everything. Surviving on an alien planet. What would it take? Let's say we somehow arrive at an Earth-like exoplanet. The next challenge? Survival. Even a planet in the habitable zone doesn't mean it's instantly livable. Can we breathe the air? Most exoplanets have unknown atmospheres, and many might lack the right mix of oxygen and nitrogen. We'd need terraforming, modifying the planet's environment to make it suitable for humans. This could take centuries, unless we bring self-sustaining habitats too. Water and food. Can we grow crops? Without a stable water supply, human life is impossible. Scientists are researching ways to extract water from planetary ice and even engineer plants that could survive on alien worlds. Radiation and extreme weather. Many exoplanets orbit red dwarf stars, which are notorious for violent solar flares. Colonists would need underground shelters or advanced radiation shields to survive. Gravity and biological effects. Some exoplanets have stronger gravity, which could impact human health. Over time, our bones, muscles, and even DNA might evolve differently on another planet. Terraforming. Can we make an exoplanet like Earth? Terraforming means engineering an entire planet to become Earth-like. This might sound like science fiction, but scientists are already exploring ways to modify Mars, and the same principles could apply to exoplanets. Some proposed methods include releasing greenhouse gases to warm the planet, seeding bacteria and algae to produce oxygen, using massive space mirrors to control climate conditions. If successful, an exoplanet could be transformed into a self-sustaining world within a few centuries. The psychological and ethical challenges of colonization. Even if we master space travel and terraforming, one question remains: should we do it? Would humans become the invaders of an alien ecosystem? Could we accidentally destroy microbial life? On another planet, would leaving Earth mean abandoning our responsibility to fix our own planet? History has shown that colonization often comes at a cost. If we ever reach Earth 2.0, we must be careful stewards, not conquerors. The final question: how close are we to finding Earth 2.0? We've discovered thousands of exoplanets, and many have strong potential to be habitable. With advanced telescopes like James Webb, we're now analyzing atmospheres for signs of life. Within the next 20-30 years, we might confirm the first truly Earth-like planet. But even then, reaching and colonizing an exoplanet is a monumental challenge. It could take centuries, or even millennia, before humans set foot on another world. So, will Earth 2.0 be our future home? Or will we forever remain bound to our blue planet? What do you think? Let me know in the comments below. Do you believe we'll one day leave Earth behind? Or is our best future right here on the planet we already have? Don't forget to like, share, and subscribe for more mind-blowing space mysteries. See you in the next video.